viewers, my name is G Sandeep, and my subject TikTok video is about power analysis. Topic is a new methodology of probabilistic short circuit evolution. Introduction. Nowadays, electricity utilization reaches many complaints due to power quality problems associated with interruptions and voltage sag. The main reason for this is increasing of usage new equipment in sectors residential, commercial, industrial, which are more susceptible to voltage variations. Consequently, it's very important to study power quality problems associated with voltage sag. The purpose of these studies is to evaluate quantity index for voltage sag to analyze their characteristics. Electrolytes use the results of studies to evaluate these performance level against the sag. Also study alternative for mitigation of their effects. Currently, quantity voltage sags assembles is carried out use two techniques: past performance applied distribution networks. In this important information of sag, where the systems can be device that collects power monitoring data voltage and the occurs voltage monitoring in future performance predictions to probabilistic technique by use of mathematical models. That solution they're widely used for methodology called sag, and the first and the approaching systems is small part analysis, each part with the fault position. For arithmetic, each one of these parts are PLM rate proportional to length of the respective part. The secondary currents of circuit, the short circuit, each positions evaluate of the voltage sag with the specified magnitude and or duration voltage safety. However, there may be significant variability around the expected value of probability index. Their variety can be assessed by the generating probability distribution of PDFs and the voltage sag the PDF. They can also use it for estimate the risk of volting targets and defined by the regulator agency associated with the voltage sag. Usually, PDFs associated with the voltage sags are generated using Monte Carlo simulation, and system cannot be modeled by complexity approach. The main aim of the paper is developed probabilistic short circuit approaches to generate the PDF associations system average RMF variation. The purpose methodology is based on combination of with admittance summation of coordinates. This combination enables of following random chair characteristics: fault state of include generations, fault type involved in fault position. The purpose of PSF approach had been generated. PDF is distributed network electricity distributed company is North Brazil. This rest of the papers is for section 2 establish the methodology used for evaluate current of fault. Section 3 describes the modeling fault random character through MCS sections PS and Safari. The result are detected in section 5 evaluation of current of fault. The evaluation of current fault can be carried using both symmetrical components as phase component. In principle, the systematic components method cannot directly be applied distributing system. This constraint is due to the fact distribution system are naturally unbalanced. Nevertheless, symmetrical components method gives result with acceptable accuracy with applied distribution network which unbalanced load or with non-transposed line. However, the symmetrical components method requires the sequence circuit of components to obtain them. Moreover, it may be difficult to obtain sequence circuits. Some transformer connections such that Scotty on the other electric network phase and their respective voltage currents and impedance without need to obtain the sequence circuit. Due to this, the phase coordinate method has been used in paper. Evaluate this current of fault. Basically, there are 4 versions of phase coordinate methodology using analysis. Fault is distributed network gas bus method and Christine method, hybrid mention method, and admittance submission. In paper, current fault were evaluated using admittance submission approaching used due to constant impedance and shunt suspectance. Further, ASM also have lower competition cost due to backward forward sweep algorithm to estimate the fault current. Equivalent circuit used in backward sweep, and figure 2 is equivalent circuit for nodal voltage set initial values YEK is equal to YLK. Backward sweep, the values YKA and JK evaluated using the equivalent circuit. DK is equal to I plus ZSIK dot VK minus 1 YE new YE old plus yek dot dk je new and ji old plus I minus ye dk and je in the word new represent that equivalent after process of branch I minus k and word old represent the equivalent before processing and same branch. Forward chip is equal to 1 product nodal voltage was equated using an equivalent circuit. We review of the model primary session review of methodology purpose of estimating faults caused by the circuit and primary feeder and node and admittance electric and the connections fault admittance at point primarily feeder the introduction of new node in electric network modified data structure used in backward for sweep algorithm. Due to this simulated that the data structure of backward forward sweep algorithm must be rebuilt consequently computationally cost can become high in applications that require large number of faults such as protection coordinate. An alternative to overcome this problem is to estimate the additional node introduction by the connection. Thank you.